an outdoor LED light that I ordered from CPC while I was ordering some electronic components, and the only reason I ordered it was because I wanted to take it to bits, as one does. I wanted to see what the construction was like, what the circuitry was like, and what the waterproofing was like. So let's plug it in to the hoppy, which is right here, and check it out. So the specification, incidentally, is a 1.5 watt rectangular LED wall light, 80 lumen, 4000K colour temperature, IP65 dark grey. And it came in at £4.15 plus VAT. Not that expensive, but it is really, having looked inside to put the flex in, it's a bit of a disposable item, as many of these things are. Let's take a look at the power rating. 22 milliamps, power factor is 0.24, which is pretty bad, but that does allude to capacitive dropper. And a power dissipation 1.35 watts, which is fine. That's kind of round about the right rating. Let's unplug it and take it apart. So having tested this, for beam angle, if you want to get some of these, I would recommend mounting at a height of about 3 feet, just above 3 feet or about 1 meter, because that way the spread of light, if you hold it, well, I just held it on my hip, so to speak, to actually do that on the side of the leg, to see what spread there was. And that was pretty much a garden path coverage. But if you're going to install these in your garden, I'd actually recommend putting a flex in one and actually holding it against the wall and seeing the spread of light out it. But it's interesting because, well, you'll see from the angle of the LEDs that if you tilt it that way, it quickly hits the wall. You can see the phosphor of the LEDs, so it's got quite a sharp angle. So it does light the wall from about this height under it. And the other side, if I tilt it the other way, this is the sort of spread you're going to get out across the path. So it's a fairly wide angle of light that comes out it. To open it, well, let's take a look at the back first. We have the standoffs, the screw mounts. We've got a couple of removable indents here for the cable coming in from the top. I wouldn't recommend bringing the cable in from the top. If you did bring the cable in from the top, I'd recommend putting a loop in it like this if you could, because that's just basically going to guide water in, and then rely on this seal to keep the water out. The other option is to take the cable in the side here, or better still, bring the cable through from behind and actually into the back of the light. I would recommend, if you do that, having some system for leaving a loop of cable, because this is effectively a disposable item. I think I may have mentioned to that. It's not something you can change a lamp in, as is the case with so many LED lights these days. If you install these in someone's garden, this is going to prove quite tricky to get off. Ugh, get out. That scares me, making a mess of actually trying to get this out. If you install this as a sort of commercial installation, you're going to have to hope it lasts for a year, particularly if they run it all the time, because otherwise you're not going to just be able to change a lamp in it as such, although technically speaking, you could just change the circuit board in it. Let's take the cover off, and this is quite interesting. It's got a clear plastic cover, which covers the circuit board, which you can see the capacitive drop capacitor there. And this cover actually seats quite tightly into a seal, so that's quite good, but it still means with thermal expansion, contraction and so on, although it's not going to get too hot, apart from sunlight hitting it would heat it up and cause that air expansion. The biggest weakness is probably the seal where the cable comes in. If you run the cables to a junction box, it's one of those scenarios that water can sometimes find its way down inside cables as well. I'm not being a pessimist, I'm being a realist. I've been there too many times with outdoor electrics. Junction boxes in the side of lampposts that you're wondering, where did the water get in? It got in along the cable, and you can actually see that in the cable. So it has this little turner block. I shall whip this cable out now, because it's not needed. It's my test cable, just 2-core. I shall put that out of the way so I don't randomly plug it in and have bare ends. So the gland here is pushed in, and you're relying on that. It's got a little lip around it to kind of seal, which will hopefully keep the water out, and the rest is down to how well the cable seals onto that. It did come with a little cap in that just pushed in. It was sort of moulded into it, and there is a tube in here, so it should form a fairly, it should do a decent job of sealing onto the side of a round cable. Make sure it is a round cable you bring in. Don't bring in a 2-core or flex or individual cores. So the rest of it just slots out like this. You can see the seal here that plastic sits in against, which is actually quite nice. And it does seem to sit quite snugly against that. You can see where it's left the indent in the seal all the way around it. This is the bit that if you had this mounted to a wall and it did fail, then theoretically you could just, if you had a replacement lamp, you could just put the light, you could just place the circuit board in. I don't know how long they'll last. I should have mentioned, each of these LEDs has 2 chips in it. I can see that because I looked through a filter and you could see the 2 little chips next to each other, and that sort of tallied up with the sort of the voltage ratings. It's a white circuit board. That is so annoying when it's a white circuit board because it makes it harder to see the outline. But tell you what, I'm going to take a little picture of this. We'll reverse engineer it. It's not really much to it. And we'll draw the schematic out and see what it looks like. So one moment, please. Back again with the images of the circuit board. Things worthy of note. The incoming supply, the live, goes to a fuse. It's an E-marked fuse. I believe that's 375 milliamps. And that then goes to one end of a metal oxide varistor, this little blue metal oxide varistor here. I've flipped this bottom image so everything tallies up. I should actually, technically speaking, that's positive, so that would be that, and that would be that. I'll just draw another bit in here. The fuse goes to the bridge rectifier and the metal oxide varistor. The neutral goes to the other end of the metal oxide varistor, which is protected by that fuse. And it also goes to this capacitor here, and there's a discharge resistor. Then it goes to a little bridge rectifier underneath, which converts it to DC, and then goes to this smoothing capacitor. There is a 330k resistor to prevent that afterglow issue that sometimes occurs, and then a really odd arrangement where they've got 4 200 ohms, that's 2, 0 and 1, 2, 0 and an extra 0, so that's 200 ohms. They've got all 4 of them in parallel to make 50 ohms. And then it goes, the LED, but just to suit the tracks, it actually goes along the LEDs like this, loops back underneath on the track, and then down the other end, and then back to the bridge rectifier. I shall show you the schematic. If you want to try a bit of reverse engineering yourself, there it is. Here is the schematic. So the incoming supply, neutral is the one that goes through the dropper capacitor, 330 nanofarad, 400 volt with its 560k resistor. Again, I'd rather see a couple of resistors across that because it's got a fairly sort of high voltage drop across it, particularly in an outdoor environment. There's a fuse at the bottom here, which just protects the whole light, including if that metal oxide varistor does anything nasty. I'm not sure, it's one of these things that, is it going to heat up if it starts progressively failing when they put a metal oxide varistor in there? Its function is probably to protect against spikes causing capacitor and LED damage. There is this smoothing capacitor, which I'd normally expect 4.7 microfarad. They've put in 2.2. That may purely be down to the fact that there's not a lot of space in here. It's quite close to that gland. The 330k resistor across that to dampen it down, that basically LEDs will light with microamps of current visibly. So to avoid having that dull glow when they're supposed to be off, this resistor makes sure that any capacitive coupling between switch cables is basically shunted through this resistor instead of going through the LEDs making them glow. There's the bunch of resistors, which, as I say, I kind of prefer a higher value of resistor in series. The main reason for them is probably the fact that when LEDs start to fail, you may occasionally get one the bond momentarily goes open circuit. This is one possible thing it could do, and when that happens, the voltage across this capacitor will go up, potentially to 330 volts, and then when that bond flashes over, it will see a sudden high current pulse. The resistors would limit that and prevent damage to LEDs, but it will also have a limiting factor on any spikes that come in and make it through the circuitry. It will limit the current through those LEDs. It's very straightforward. There are 12 LEDs, each has 2 chips in it, in series. I could double check that. I could double check that by using continuity and then seeing if I can make an LED light. If I can make an LED light, they're in parallel. Because this unit won't usually light 2 LEDs in series. So there's the positive is going through there. The positive is going to this end of LED. Am I going to be able to make it light? No, I'm not going to be able to make it light. That is almost certainly 2 LEDs in series. Okay, that's kind of what I'd expect anyway. It's a good way. These capacitive droppers work best if you have a high voltage string of LEDs. So that's the equivalent of putting 24 LEDs in using the double chip LEDs. So what do I think about this light in general? I've got mixed thoughts because I quite like it. I like the fact it's got these little brass inserts. I like the fact it's got a little waterproof cover that clamps down over that inside and makes it nice and tight and waterproof. It puts out a nice spread of light. I'd actually like this indoors, but I have to say, it's the fact that it's a consumable. You can't change a lamp in it. I mean, you can change the circuit board if you're skilled. Talking of which, warning: don't touch PCB after connecting power. Do you have to tell modern electricians not to touch live things? Is that what 1 week training has done to the industry? But you can change the circuit board if you're technically competent enough to like pull it out and plug it in. If you can think that far ahead, I'm not going to say that. But the other option after that, if these start failing in the wall of the house, you can't just change a lamp. You're hopefully going to have a long enough cable that you can put a new one in if you can get a new one. But this is one of these things that with unserviceable lights that you can't change lamps in, it's encouraging homeowners, because of the increasing costs of using electrical contractors, because of a protection racket going on. It's encouraging people to do more and more work, and having someone kneeling in their wet garden poking around trying to change a complete light fitting is not a good idea. But indoors, I would be very tempted to put a Patras box in the wall, a standard 2-gang, and mount this in the back plate. That would not only be a nice way to mount it to the wall in a way that could be easily changed for different size fittings, but also when one did fail, you could, if it was a regular thing in a sort of a care centre or something like that you wanted to illuminate the floor, because I have to say that the way it spreads light out is really nice. It does it well below eye level, so it just basically lights the floor below your feet. It's quite a nice effect. But if you wanted rapid service of them, it would simply involve having some of these mounted plates, unscrew them, and something like one of these sort of Wago-ish terminals at the back, just to actually disconnect and connect the new one in, and then screw it back onto the wall again. But the construction is nice. I do like that. I'm not a fan of disposable light fittings, but the construction is fairly nice. Not sure how waterproof it will be. My experience of waterproofing is such that it will probably not be waterproof, just because that's what happens. I wonder if the reason they've used the heat-proof cables in the vicinity is because they're close to that little metal oxide varistor. But I do like the construction. If you did get some of these for your house, I'd recommend, they're not that expensive, I'd recommend buying spares for the future and just making sure that you did allow for serviceability. So they're quite neat. It is a standard capacitive dropper as well, nice and simple. Those of us of technical persuasion could change the LEDs if we wanted, because it's not even a aluminium substrate PCB. They're running at such a low temperature. These are just running in the region of about 20 milliamps. That you could just even if you didn't have the double chip LEDs, you could put the single chip. It wouldn't do any harm. But you could replace LEDs yourself if you wanted, but that would be a total hobby thing to do something like that. For the other option then is, as I said, without removing this backplate off the wall, if it was fairly dry and clean inside, you could just swap the circuit board. But there we go. It's interesting. It's a nice enough light fitting, but it is disposable. But anyway, that's not uncommon for modern LED fixtures. It just seems to be the way they've gone. So that's it. It's a nice, simple little light. It produces a nice spread of light. It's functional. It's simple. The LEDs aren't being really grilled, so they should last a decent length of time. But if you do, as I say, if you do order some, get some spares just as precaution, because then you can just swap them straight in. Other than that, I would say it's quite nice. I do like it.